And okay, so I have some quests from real life to do some integral problems. So I'll do some integral problems with you guys. And I'm using the metric 7th edition of James Stewart Calculus. If you open up to 523, page 523, we'll be in the same track. So the first question is, what is the integral? Oh, sorry. What is the integral of cosine x plus 1 plus sine squared x dx? Now, this seems like a really complicated integral, but it's actually not. Now, let's think about it. So, first of all, we have to recall the properties, right? Of the trigonometric properties. The first thing we have to recall is that sine squared of x plus cosine squared of x is equals to 1. Therefore, sine squared of x is equals to 1 minus cosine squared of x, right? And cosine squared of x is equals to 1 minus sine squared of x. And the reason why I did this is because, look, the 1 plus x squared, 1 plus sine x squared, this is the reason why. So, if you see some kind of expression like this, it's always nice to try out this equation. Because, who knows, it might work. And you can replace this as a cosine squared function, and it works much more simpler that way. It's much of a nice function. But, this one failed, right? So, we have to use another way. But, guys, if you're used up to do integration in your own speed, do it in your own speed. Don't see this, because it might just end up confusing you a bit more than usual. Wait, I suck at measuring camera angles, so wait, here. Okay, the first method failed. The second method I'm going to use is this. I cannot use trigonometric substitution or any nice law. So what I'm going to do is use the u substitution. What does the u substitution have to say? We see both nice sine of x here and a cosine of x here, right? What do they have? Recall that the derivative of sine of x is cosine of x. You get the idea that this might work, but let's see if this works. Okay, so we get u equals sine of x. Let's make a u equals sine of x, okay? And du is equal to some cosine of x. Remember, if you're saying d, differential operator of u, then it means you're finding the derivative of that function, so it's cosine of x. And since cosine of x is a function with respect to x, not a u function, so it's dx. Okay? Let's go further on this question. And so, this is the hard part. It's the integral. What did I say? U is the cosine of u is the sine of x. Du is the cosine of x. So basically, we can rewrite this as the integral is the following: 1 plus sine squared of x, right, times cosine x dx. And because of u substitution, this here will be du. This here will be du, okay? Remember this, don't forget this. This is important. This here will be du by u substitution, and this here will be u squared, because remember that sine x squared is also the same thing as sine squared of x, okay? So don't panic here. And we can finally rewrite this as the integral 1 plus u squared du. What an amazing function, right? So it's so much simpler. Now this, okay, now don't tell me you don't know how to integrate this, but the integral of 1 du is du, and integral of u squared du is 1/3 u cubed, plus the constant of our integration. Excellent. And then we get the final answer, sine of x. Remember, we're just plugging in x, the value of u here, okay? Plus 1/3 sine cubed of x, plus a constant of integration. This will be our final answer. Why don't you try another one? And yes, this might get tricky. And by the way, I'm a senior in high school, so let's be easy. Okay, the second one, which I don't think you guys will struggle much, is a definite integral. So what is a definite integral, by the way? So a definite integral has the following form. Yeah, this one is a bit trickier, but okay, by the way. The integral 1, 0, okay, integral 1, 0, not 1, 6, 1, 0, 3x plus 1 over the square root of 2 dx. Okay, now this is tricky. You better pay attention to this. This is the type of function that no one likes, okay? Because of this root here. But this sounds familiar for me. Remember, in high school calculus, you learned this, but the integral b to a to b, okay? The integral a to b, sorry. The integral a to b, from ax plus b to the nth power dx, right? Is equals to 1 over n times 1 over a over 3x plus 1 over x plus 1 times m plus 1 ax plus b m plus 1 plus c. So why don't you try out using this formula? M plus 1 plus c. So wait, sorry, camera configuration is wrong. Put this one here, like this. Okay, like this. Sorry. So we take the interval of a to b, ax plus b to the nth power dx equals to 1 over n times 1 over a, ax plus b, n plus 1 plus c. This is what you want to get to. So we know that our constant is 0. So we use the basic u substitution. If u is equals 3x plus 1, du is equals 3 dx. Okay? This means that du dx is 1/3. So we can end up saying 1/3 times 1 over the square root of 2 3x plus 1 or 3x plus 1, yeah, 3x plus 1 over the root 2 plus 1 plus c. Okay, so remember that the square root is not treated different from any number here in this case. So we get the following. We get the following of the 1 over 3 root 2, 3x plus 1, root 2 plus 1, plus a constant. This means we have to simplify the denominator here. So we get 1 over 3 root 2. Remember to take out the square root radical. We have to multiply by the root 2. And the same thing. So 3x plus 1 over root 2 plus 1 plus c. And we get 1, the root 2 of 6, 3x plus 1 over root 2 plus 1 plus c. However, if this was an indefinite interval, we can solve like this. Easy. But this is a definite interval, so things have to change a bit here. Okay? So we're not just we don't want to just plug in the values of 1, 0 in this equation, because what we're actually going to getting up is some unusual typical function. So you don't want that. So I will arrange my equation like this. I told you in the beginning that u is equal to 3x plus 1, right? So why don't you try like this? Instead of doing this way, okay? This is the typical way of how people solve this. After you got every integral terms, you'll just plug in the 1 and 0. But in this case, this just makes it complicated. So, and the book doesn't require complicated stuff. And so, let's try this way. We said use 3x plus 1. We said that. Why don't you apply that? So, to apply u equals 3x plus 1, we have to consider the integrand. The integral was this. So if you plug in u of 1, then we get 4. Yeah, 4. U of 0, we get 1. Okay, so it's basically the same thing. It's the integral 4 to 1, 1/3 times 1 over the root 2 times u to the root 2 du. It's the same integral here. What we wrote in the beginning and in the end, it's the same integral here. And we can conclude that root 1, 2 is actually u to the something to the 1/2 power. No. Yeah, but we end up with this, so we end up saying 1 over 3 root 2 integral 1, 0 u root 2 du 4, 0, 4, 1. And yeah, we get a much simpler function. So we know that because of here it is root 2 over 6 times u to the root 2 plus 1 over root 2 plus 1 over 4, 0, 4, 0, 4, 1. And we get following here. So root 2 over 6 times 4 to the root 2 plus 1 root 2 plus 1 plus 1 to the root 2 plus 1. And we want to get things out. But I think this is what the book wants as an answer. So I'll leave it here. I'll end it like this. By the way, in tests, you just think of finalizing fully simplifying the answer. Since I'm running out of time, I'll end my video here. I hope you enjoyed.